Hey everybody, how's it going? Thanks for braving out the weather here. We're still waiting for a speaker, but Jeff from Object Rocket is helping sponsor tonight. So I want to give him a few minutes to talk, and he has to go. But you're gonna have some people here that can
talk afterwards. Yeah, our recruiter's supposed to show up, so he'll be upstairs.
All right, great. Well, all right.
Thanks, man. You're right. Nice. How you guys doing?
Good.
It sounds like it's nasty out there. So there's Matt right there. So hey, my name's Jeff Duffy, and I am the lead developer at Object Rocket. We are a Rackspace company, thus the sponsorship, and we do MongoDB as a service. Hopefully some of you guys have heard of or have used Mongo. And we're hiring. We're growing pretty fast, super fast. A lot faster actually than we expected to even 2-3 months ago, and so we're definitely on the hunt to find some experienced developers. Really interested in finding guys who have UI and UX experience. Of course, if you're heavier on the back end, that's perfectly fine too. Our stack is Python and Flask, right? We do some, jQuery stuff. We use Bootstrap like every other company on the planet, you know what I mean? So, but we're at a really exciting time right now for people to join us because we recognize that there's a lot of room for improvement, both in our UI, some of our processes, the way we do things. The development team's still really small. I got 4 other guys looking to make that a lot bigger in the next 3 months. So if you're interested in an opportunity to come in and actually have some influence and really be able to make a difference in terms of the quality and the sexiness of our application, you know what I mean, then this is a great time to do it. Also, one of the things I talk to people about when I pitch coming to work for us is the fact that we're kind of in a unique position. So we're here at the Capital Factory right now. It'll probably stay that way for a little while, so that's kind of nice, right? We're sort of independent and doing our own thing. Rackspace has been a great parent company because they give us the resources we need to get things done, but they're not too overbearing in terms of making us do things that we don't like to do. So you get both benefits. You get to basically work in a startup environment where you get some of that flexibility that you look for when you're working for a startup, right? I mean, I'm pretty easygoing when it comes to not making people come in before 9:30, 10 or something like that. Wear whatever you want. It's okay if you want to look at Reddit every once in a while in your box while you're working. No one cares about these kinds of things. Output we care about, right? So, but here's the other great part: you get health insurance, guaranteed paycheck. The stability of a company with 5,000 people, and Rackspace is one of the best places to work in the world. So. Anyway, Matt back there, raise your hand. Matt is our recruiter. He is going to be here later today after all of the other festivities have happened. Unfortunately, I cannot stay. So Matt will be here if you are interested. Please contact him. Again, Object Rocket, my name is Jeff Duffy. I look forward to hearing from a whole bunch of people from tonight. Thank you.
All right, thanks, Matt. Thanks, Jeff.
Okay.
Thanks, Jeff. All right, Matt, do you have anything to add to that? Or?
Yeah.
All right, cool. Just getting it over real quick, and then we'll start festivities.
Yeah, I won't take up too much time. Yeah, as Jeff said, I'm Matt Allen with the Rackspace Talent Acquisition team. I just wanted to come out here and network with some of the Python community. Hoping to be more of a regular face at some of the events like this, and I'm not here to hard recruit anybody or anything, but I am here to help answer any questions that anybody might have in case they were interested in what positions we have open around our development needs, which are several right now. We've got about 20 open here in Austin alone. Our Austin office is now up to about 550 people. So right now we're looking for developers to work on both our platform as a service offering. We're also looking for some folks to contribute to our OpenStack Keystone initiative, as well as with some of our other platform related teams. And of course, as Jeff said, our Object Rocket team is growing like crazy right now. So it's a great opportunity for those that are interested in data services and things of that nature. So I'll be hanging out in the back. Come say hi, tell me what you're working on, tell me what you're building. And if you have any questions, like I said, I'll be happy to answer those and let you guys get on with the rest of the meetup. Thanks.
Thank you. Thanks, Matt. All right, so let's get started here a little bit. So some announcements, a few things going on. You may have heard of PyCon. It's happening in a couple months, and it's in Montreal. So if you don't have a passport, don't even try. If you do have a passport, you better sign up quick because I'm sure it's almost sold out or soon to be sold out. And then we have coming up, there's a High Texas, the leadership board, looking for volunteers to help out. Yes.
I'm trying to get it to come.
High Texas leadership board. I'm trying to influence it to come to Austin. It's been in
Someplace next to Brian.
that other place. Texas A&M.
So if you put together a first group, because I've been talking to people about a venue for
I said 68.
In Austin.
in Austin. See, I go to the main pipe, I never come to this one.
Okay.
I came because it's class. So I mean, if you're serious, I've already got something, maybe almost lined up and everything.
Well,
They went all silent when we tried to get them to give us a bid package. They never replied. And so
We should talk about that at the leadership board.
yeah, we should get Jeremy. We'll get if you find one of us, myself, or Dave, or Josh, and we'll get you in contact with Jeremy, and we'll see if we can make it happen. I know that this year I think it's gonna. There's set on it has to be in
it's already set.
College Station,
It's
but
for 2050.
yeah, cool. All right, awesome. Anything else? Anyone else that wants to add? Did you find it particularly warm outside today? Because I know I did. It was hot. Anyway,
Daniel, I found that.
oh yeah, well, January-thon isn't quite going so well. Back in January, or back in July, I had a baby boy, so July-thon last year, sort of, I'd like spent all my time working on July-thon and having a baby, and then I just went in hibernation after that. So I didn't get much prepared for January-thon, but we are working on the third installment of July-thon, the actual event in July. I'm going to try and do a refresh and pivot a little bit to focus on individual contribution. So you will get a dashboard that says like how you're doing with the statuses of like, oh, you did 100 commits so far, and you get a badge for various levels of accomplishments that you made. So hopefully if you are interested in helping us out, you can find myself or Josh and look you up. And other than that, I think we're ready to talk. Kurt, who's one of my fellow coworkers at Rackspace, wrote a pretty cool web app, whiskey framework, sorry. And he's here to talk about it.
Okay, appreciate everyone coming out, braving the crazy storm outside to be here today with us. So, like the man said, my name is Kurt Griffiths. I'm a cloud hacker at Rackspace, so I get to play around with all kinds of cool stuff all day long. And I just want to take the opportunity today to talk to you a little bit about not just this little whiskey framework that we came up with, but I want to go over some kind of design philosophy that went into it, and I hope that you can kind of take that and apply some of the things that we learned in creating Falcon to your own projects. So, at Rackspace, I spent a lot of time thinking about things like performance, security, reliability. When you're operating a huge public cloud, it's a big deal to keep these things in mind, right? And if you sort of ignore them, the consequences can be disastrous. So everyone's, I'm sure, familiar with what happened here with health.gov. The load that the world is putting on our servers, on our services, on our apps is already huge, and it's only growing. We have to be prepared. So not only in terms of performance, but thinking about security and efficiency. So I'm going to break this down into two parts. Start out giving you some background on where Falcon came from. Then I'll show you some code so you can get a feel for what the Falcon route looks like. And then we're going to kind of dive down into the guts of Falcon and try to expose some of the performance patterns that really make Falcon fly. With the hope, again, that you can kind of take these and leverage them in your own work. So about now is when I get everyone thinking. I usually get the question, well, Kurt, aren't you just like reinventing the wheel? Because there's like a million whiskey frameworks, right? And does the world really need another one?
A million bad whiskey frameworks.
Yeah. So I think the world actually does need another framework, obviously. But it goes a little deeper than that. I actually wish that more people would reinvent the wheel more often. So here is a picture of a wheel from the Model T Ford, right? So imagine if we had stopped with this design. Where would we be today? If you just go into Google Images and you search for wheel, you'll get something like this. There's a reason why all of these exist. It's not just a matter of improving upon what's come before. It's also building the best wheel for the application, the best tool for the job. So I'm a big believer in sort of encouraging this Darwinian ecosystem of different ideas and projects, allowing them to organically bubble up and move our industry forward. So all this kind of, the story with Falcon started actually about 1.5 years ago. I had this project I was working on, and we had to serve requests for like an insane number of clients at the same time, lots and lots of requests, lots and lots of individual clients. So when we started looking at the backend service that was going to power this, we knew we needed something that would scale and be fairly efficient because we didn't want to have to deploy 1,000 servers to run this thing. The other thing that was really important to us when we were looking at this project was response time. There was the control panel was going to also be talking directly to the service. And if any of you guys are like into usability design, you know that people hate the wait. And if you take, the response time is under a second, it's about 1/10 of a second, you need to respond. So the users will feel like it's a real-time engaging experience. And if you don't respond that quickly, more often than not, they'll leave. And they'll go to somebody else's site, or they'll just get frustrated. And they can't build these amazing experiences that we want people to build on. So I went, we decided we were going to build this thing in Python. And so I went kind of on the hunt for my tools. I need to build up my toolbox, right, to build this thing. There are kind of 3 things I look for and evaluate. Yes?
So you just started with a major performance issue. And you said you decided to build on Python.
Yes. Well, there's other factors that kind of, yeah. So that was our constraint.
You just stepped over a huge issue.
Yes. So we're given this huge challenge to deal with. How can we get the most out of what we have to deal with? So I started looking at these different criteria that I could evaluate a framework that could kind of fit the bill, do what we need to do. These are some things that I've kind of evolved over time. Sorry, this is kind of weird.
You just turned it up a little bit. You pulled it. Yeah.
Okay.
A little hard to get back.
Okay. Sorry.
No, you're doing great.
Okay. It's always weird talking on the mic, right? Okay, so, all right, let me back up a little bit, get back on track here. Okay, so over the years I've kind of come up with these three things that I like to use to evaluate frameworks or languages or libraries. So I pulled these out of my toolkit and I started looking at them. So let me just hit on each one of these real quick so you understand what I was after when I was looking for a risky framework to solve this, these needs that we had in this project. Okay, so the first one here is Elegance, and I have here a picture of a stereo that was actually designed by Rams, who is kind of this iconic industrial designer. And actually, whether or not you're a big fan of Apple products, you have to admit they do a pretty nice job designing their hardware. And pretty much everything they do is based kind of on his pioneering work. So you might say that I'm a software minimalist, and I like to follow that mantra. Rams explained his philosophy towards design when he said that good design is as little design as possible. And what he's talking about, not that you don't spend the time, it's actually really hard to design things that are minimal. But what you do is you put the focus on the essentials, the things that really matter, and you don't get burdened and weighed down by the stuff that you don't need. The things that just distract from the functionality of what you're building and the aesthetic beauty of the thing that you're building. If you look in, so I'm a Mac user, and if you look on the dictionary in Mac, sometimes they have a sidebar where they have a working author that will comment on the word. So if you look at elegant, we get something like this. Okay, so I'm not sure the guy's name, just left in his initials, but he said that when you say that a fastball or a legal brief or a dance move is elegant, you're saying that you admire not just its beauty, but also its efficiency. That it gets the job done with surprisingly few wasted components or motions, and even with an ingenious shortcut or two. Okay, so let's build on that idea a little bit more. And let's look at this this quote from the famous French aviator and philosopher, Antoine. I'm not going to try to pronounce the last name, but he's the guy that did like The Little Prince and stuff like that. So he thought a lot about, obviously aviation, and he was talking about designing aircraft, and he said that perfection is finally attained not when there's no longer anything to add, but when there's nothing left to take away. So it's really interesting. It kind of turns that on its head. Okay, so I've kind of over the years pulled all these together and made this mental model that I like to follow when I'm approaching software design. The idea that you take something that's, you take something and you try to make it as simple as possible, and also, but still it has to be usable, it has to get the job done, right? But if you can make it as simple as possible but still get the job done, that's when you get a really elegant design. Okay, so that's the first criteria that I look at. The second one is, I love things that are versatile. So this is a RoboGrip. I don't know if any of you guys have one, but this is like my favorite tool in my toolbox. I got this and it replaced like 6 or 7 of my other tools. Pretty awesome. Like, it looks like a simple thing, but the magic in tools like this is this thing called affordances. You may or may not have heard of them. I think there's a book called The Design of Everyday Things, kind of popularized that notion. But before Donald A. Norman, who wrote that book, there's a gentleman who sort of pioneered that early concept. He was a psychologist named James J. Gibson, and he defined an affordance as something that is just an attribute of the environment or a tool that makes possible an action. So you're not directly embedding those mechanics in your tool, you're giving a set of affordances so people can kind of choose their own adventure. They can wield it in ways that you may not have even imagined. So I mentioned Donald A. Norman earlier, and he talked about that a lot. He liked to say that when you can tell when something's been really well designed because people can take it and do things that the creator never even imagined. So that's the other thing that I like to look for when I want to reuse other people's code or design my own code. So the last thing I just wanted to touch on before we introduce like Falcon itself is this idea of efficiency. So here's this maglev train, kind of like, poster child for efficiency. It gets rid of all the friction, and you can travel at insane speeds with a relatively tiny amount of energy compared to what it takes to drive a traditional wheel-based train. So this is better for the environment. It's better for passengers. They get a smoother ride. They get there faster. It's better for the economy because people can kind of get places. You can kind of do city planning around it. So efficiency kind of brings in a lot of interesting possibilities. Just to make that a little more concrete, I like to define efficiency as basically how much useful work can I get out of something when I put something on. Plenty of examples. If you're an ad serving company, you might measure how many ads I can serve per kilowatt hour because the data center's charging me by that, or because I want to be green, or some more traditional things. You can just look at like how many requests per minute or per second per machine I can serve, and that kind of thing. When you focus on efficiency, you save money, you help the environment, obviously, because you're spending less electricity on things. But you also save in ops costs, and you have fewer things to worry about in production because you just have fewer boxes. Now, Scott Weiss is a venture capitalist and with Andreessen Horowitz, and he's kind of talking about this trend I alluded to earlier, where modern web apps and data centers have to handle huge amounts of loads. He talks about thousands of requests per second, terabytes, hundreds of customers, but it's not uncommon to see those kinds of things double, tripling, 10x. In the next few years, we're talking more like millions of people, hundreds of thousands of requests per second. So it's really important, as health.gov kind of demonstrated, to plan for these kinds of things. And then also, I talked about earlier how it's not just how the efficiency is also related to latency. Generally, when you make something more efficient, you're doing less work and you're able to turn around answers faster. And Jacob Nelson is a pioneer in usability, and he found that about 100 milliseconds, 10th of a second, is about the limit of people's patience before they start noticing serious lag. So that's not a lot of time to get things done, especially when you consider having to make some hops, do some work, hit the database, maybe hit another service, bundle it up, come back. Okay, so you gotta look at the whole pipeline, and there are lots of parts that can be bottlenecks. I'll talk a little bit about that later. But so the idea is latency is important, efficiency is important. So I had these three things in mind, and I went to look for a framework out there, because there's tons of Python risky frameworks already. I'm a big fan of other people's code, OPC. I like to use other people's stuff, right? Save you some work, you learn some stuff, whatever. So I didn't sit down to write a new framework. I set out to find one that someone else had written. Surely there had to be one that would do the things that I needed for this project. So I started looking around, and as I mentioned, there are all kinds of frameworks out there. I tried to pull some of the more popular ones, play around with them. But as time went on, I started to get discouraged. I just was having trouble finding that elegant, clean framework that I needed to build an HTTP API. They all seemed to be, come with a lot of baggage, or they weren't fast enough, or too many compromises. So
So
Yes.
you're now saying you're just focusing on being an API REST server.
Yeah.
Because there are things up there that could be that, but they also all have these templating languages and a bunch of other things. Right?
That's correct. That's correct.
So you'll find yourself down to an API only server.
Yeah. I'll touch on that in just a minute. Good questions. Okay, so it was about this time that I kind of come to grips that like I can't find this thing that I need, and I remembered something that I actually learned from my grandfather. He was a professional carpenter for a number of years. Did a lot of amazing things. He was kind of like that true like master craftsman. And there's one thing that when I was going through this process that I remember noting about him, that that the tools were really important, right, to his work. And he would go through and he'd be working on something and he'd come across a task he had to do, and he didn't have the tool. So in that situation, you can either kind of make do, or the alternative, which he would often opt for, was to go and make it. He would actually make his own tools sometimes. He would take the time up front to invest in making that, so that for years to come, he would have that tool and he could rely on it, and it would save him a lot of time. So I decided to give that a try. Oh, hold on. My slides got out over. Never happens for me. Okay, it's all good. Okay, so I like kind of designing from outside in a little bit. I like kind of having a mental like image of where I'm headed. I came across this this diagram in Wikipedia. Kind of talks about compares the different wings and body shapes of different birds. Nature is like really good at figuring out how to like design bodies to kind of fit the unique circumstances that the animal has to live in and the things it has to deal with. So again, I think it's really important to have multiple choices so you can choose the best tool for the job. But I was looking through this and I thought, the Falcon, that's it. That's what I'm trying to build here. That's what I need for my project. So I kind of took that as the mascot. And it really just kind of helped me center on, have a philosophical center for this framework as I designed it, to keep it on track. Because again, I'm a big fan of kind of minimalist design and building things that have just as much as you need and no more. So here's before I get into this, we're going to show some examples of what a Falcon app looks like. To the gentleman's point, Falcon is a WSGI framework that was specifically designed for HTTP APIs. APIs that would power modern web applications and mobile apps. So you'll probably recognize a lot of familiar patterns from other frameworks, web frameworks you've come across in the past. But here's just a sample of what's going on here. Very, very simple, obviously contrived. You create classes that correspond to resources, and then you have methods on those, so that's kind of a common pattern, right? I believe you'll see something similar from like the Tornado framework. And you just create that API, and you add routes to it. Pretty familiar, right? And so it's kind of designed to be really familiar, and just you can sit down and just get started right away. So some more advanced things that Falcon can do is, of course, it's got the usual hook mechanisms. You can do global hooks, resource hooks, method hooks. you can do these URI templates in your routes, so it can pull things out. Again, I'm trying to code something that's more forward-looking, so instead of using kind of the traditional colon name, I'm actually trying to use the RFCs for like URI templates and track those kind of as they evolve. You can add error handlers. So if you're familiar with Flask, you would normally do this with decorators. But I wanted to find a way to keep kind of the magic out of it so that you always know what's going on and how things are attaching. So it's easy for a new person to come pick up the code and understand it very quickly. And removing some of that magic also allows you to go faster. So Falcon tries to be very productive, but occasionally if there's a decision between developer productivity and performance, as long as it's not a huge loss in productivity, we'll tend to go for the performance. And just some more examples of things you can do with it. So you can get parameters. That are coerced to different things. You can actually pass like a lambda function in there or whatever to convert things. If you raise these kinds of HTTP exceptions, it'll just automatically get translated to sort of idiomatic HTTP responses. It has a lot of stuff in there to try and encourage you to design usable APIs. So you can set descriptions, error codes, hrefs for your errors. And of course, you can do the usual stuff and set headers, set the status, all that stuff. So this is just a quick, so Falcon doesn't try to get in your way. It doesn't try to do too much. It gives you direct access to like the request stream. It doesn't try to manipulate it or cache it or anything. You can certainly do that by adding your own hooks. But the feeling is Falcon should be a foundational framework for you to build up your own toolkit on top of. Part of the problem is when you start trying to do too much for the developer, it's really, you take away some of the trade-offs and decisions that the developer can normally decide on themselves. So, Falcon's real, it's out there. Before I get to the second part, you probably might have seen the website because it was linked in the meetup notes. It's actually, it's about a year old now. We've got 14-ish contributors. Contributor list keeps growing. And actually a lot of people are using it for real stuff today. So it kind of started as an experiment, and I wanted to put it out there and just see what would happen. It's kind of taking a life on its own, so I'm really happy about that. I'm glad that people are able to make useful stuff with it. So we use it at Rackspace. We have a team to use it. We've heard from a bunch of people who are kind of using it on side projects and startups and stuff. So it's going to be interesting. It's still pretty young, but I want to see how far a minimalist framework can take us. So that's kind of a whirlwind tour of the philosophy behind Falcon and a quick introduction to what Falcon apps look like. So here's the second part, and while Falcon tries to be elegant and things like that, kind of its key attribute is its performance. So this is just kind of a comparison of some popular frameworks out there compared on, not a hello world app, something that's a little more meaty than that, but enough that you can kind of get a real idea of the performance when you're actually doing things like setting headers and parsing query strings and stuff.
There's no database query behind any of that.
No, so, right.
Was the y-axis there just milliseconds?
Oh, sorry, I should explain that. Yeah, actually I think that might be microseconds.
So, yeah, so you're probably saying, why does a microsecond matter? So I actually need to go back to this slide out here that I know I had moved, but I don't know how we got back. Okay, so when I started working on Falcon, I first did some experimentation. So I created a really basic vanilla whiskey framework, didn't do a whole lot. Called it RAR for, I don't know why. But, seemed like a good idea at the time. And I actually built out like a real like web service, as real as I could make it. And it actually did have, have to go back and hit a database. It had to do, routing, had a big route table, had to do all kinds of stuff. So it was like the real deal. A lot of benchmarks you see are just like hello world and that's it. So, so I took that and I wrote the same thing in Node as well, kind of as the, I don't know if you want to call it the gold standard, but I thought it was a pretty good baseline for comparison. And so you see that top there, so I'm running these as G-event workers on, I think it was G unicorn process, just one process, try to keep it simple. Try to remove some of the variability in benchmarking. And so that's kind of that orange line you see here. The blue one, blue and red are pretty much the same. So I basically just took it and compiled it with Python. Like didn't put any Python extensions in it or anything. So that gives you 1-2 millisecond per, boost per request. And I honestly wasn't expecting much of a difference because we gotta go hit the database. That's always the bottleneck, right? But I was surprised to find that as you increase the load, and especially when you're doing a lot of concurrent requests, so along the bottom here is the number of concurrent requests attempted per second, and up and down there on the left you've got what we actually were able to achieve. So just by shaving a millisecond or two off the whiskey framework, still doing the database, everything, we're able to get up to another 150 or so requests per second. So I thought that was really interesting. So it turns out that when you have a lot of parallel requests, if you save a little bit of time in each request, then that avoids getting things kind of stacked up and backed up. So if you have a lot of requests happening in parallel and they're all kind of going slow, and you're actually doing this on a single in a single process, well, eventually you start to become CPU bound. So making your framework a little bit faster, your app a little bit faster, actually helps you to stretch out that cliff there for a little bit longer. I also talked about latency. There's actually even more, there's a bigger difference here with response time when you do this. Then you've got the kind of the G event just running regular Python there. But then when you can pile it with Python again, save just a tiny bit per request, get this huge decrease in latency. So you can go up to, you can handle a much bigger load and still deliver a great user experience.
What is the x-axis there?
Oh, sorry, yeah. Again, this is going to be attempted requests per second, and then actual, oh no, that's going to be milliseconds. Yeah, that's going to be attempted requests per second, and that's going to be your response time, so in milliseconds. So 500 knots, half a second. So you see here, we just kind of hockey puck there.
So the only difference between the G event and the G event dash sidewall is you use Python.
Yeah, I just compiled it with Python. I didn't actually do any.
So you got another 500 requests per second just on using Python.
Yeah, so if you say, our goal is to keep our response times under half a second, then you would look at where that intersects and say, oh, look, we could handle a bigger load and still be, meet our latency goals.
So that's a great result for all of us, because just moving to Python does wonderful things.
Yeah, it's really, and it's actually pretty easy because you don't even have to put any Python decorators or anything in your code as a first step. You can just compile it, and you kind of get an instant boost. And Falcon will actually compile itself with Python if you have it installed. It doesn't have any extensions or anything. That's kind of wanted to do this, but it'll give you a little speed boost there too. Okay, so let me fast forward here. Okay, so we touched on this a little bit earlier that, of course, you do have to worry about external things to your app. You got to worry about your database, your network, right? Those are definitely opportunities to improve your performance, your efficiency, your latency. And there's certainly an opportunity with working on your algorithms. If you study computer science, you're familiar with Big O. It's basically just a way of calculating the sort of relative complexity of an algorithm. So if you can choose algorithms that are less complex, then your CPU has to do less work, and then you get faster. So I'm not going to touch on those so much tonight, but that's a huge opportunity for improving the performance of your app. So the other thing that I will talk about is code tuning. So it's kind of the other side here. And a lot of people talk about how, this often falls under the bucket of premature optimization, you don't do this or whatever. But given those other graphs that I showed you, if I can save a microsecond here, a microsecond there, and that adds up to several milliseconds, that's actually a big deal. So some techniques I used as I went through this to kind of learn how to tune Python code. I looked at prior art, which is always a good idea. You go and you search the internet, you look through your Python cookbook, and a lot of them will have little nuggets. They'll say, oh, well, this thing's a little faster. Okay, so you can also look at other frameworks. There's the OpenStack Swift project wrote this thing called Swift Swab. It's kind of was a replacement for WebAuthn because WebAuthn kept changing the interface and breaking them, and got tired of that. So they wrote their own thing, and they actually have some pretty good tricks in there. So I was able to learn from that. So definitely when you're starting down this process again, look at other people's code, see what you can learn and borrow, because they're all building on each other. I'm a big fan of IPython. If you're not familiar with that, it's kind of like a super REPL for Python. And it has these magic % commands. One of them is time it. So it just kind of pulls in the time it module and makes it a little easier to deal with. So I always have a IPython session open on my desktop, and whenever I start putting something in there, I ask myself, well, is this the best way to do it? Is it as fast as it should be? Or I come across a tip that I read on the internet. I don't just use it, I go and try it. And it's important to do that because things will run very differently depending on what version of Python you're on. And a lot of the tips that you'll find can be pretty old or outdated. IPython also gives you a handy way to run cprofile. And that's obviously always a great way to kind of zoom in on your bottlenecks in your code. I also wrote this thing called Falcon Bench, which just compares, runs Falcon in a kind of a sandbox environment. It runs several other web frameworks, and kind of does a non-trivial web request, where you actually have to do a little bit more than what you do in a Hello World app. It's still contrived, but it gives you a rough idea of how you're doing. And even more than using it to, it's not so much to compare against other frameworks, but it's to compare to previous versions or different experiments that you're running with your code. So as I would experiment with different things in Falcon, I run Falcon Bench, and I noticed that kind of threw things off. So there's one extra test in Falcon Bench that does has a big routing table and tries to simulate more closely like what a real web service would do. That's really useful for kind of like A/B testing. And then there's this technique I like to call fencing. So sometimes it's even with C profile and some of these other tools, it's still kind of hard to pin down exactly what's taking that much time. So fencing has been a common technique in debugging for a long time. You kind of comment out some code, and then if the bug goes away, then you know, hey, it was there. If it doesn't, then you kind of dissect that code or that logic path, and you keep kind of shrinking down that area until you home in on where the bug is. So you can do the same thing with performance, right? You can like just not do something and see if that makes a difference. For example, you might say, well, I suspect that the URL library is pretty slow. I don't know, maybe not. Let's just not decode the query string and see what the performance difference is. So useful for debugging, useful for performance testing, useful for all kinds of good stuff. All right, so let's actually get into some meat here. I'm going to show a bunch of. Let me just check how we're doing on time, guys.
I'm good.
We good?
45.
Okay.
449.
Yeah.
An hour and 15 minutes.
Because I know you guys just want to listen to me talk for another hour and 15 minutes. don't you?
We're here to grill you.
That's right. Yeah, I saw the rack in the corner and so can crank me up. Okay, so let's actually look at some code. I split this up to kind of what I call basic, intermediate, advanced patterns. It's kind of loose, but just kind of the main thing to think about is like they kind of build on each other, and some are more obvious than others. So some of the basic patterns that I learned early on was to use this slots thing. Now, in more recent versions of Python, it doesn't give you that much of a boost, but I'll still do it because like in Python 2.6, it's pretty good, and it's not that hard, so why not? So you use the slots thing, and if you're not familiar with it, it sort of predefines all the buckets that you can put data in for that class. So when you do that, Python can kind of take some shortcuts when you're accessing attributes on your class. You can kind of pre-allocate this static struct basically in memory, and it knows what things you have. So it actually saves some memory and makes sure when you do self dot whatever, it makes that look up a little bit faster for you. So this is actually, obviously the request class from Falcon. Okay, so this is the initializer for the response class, and you'll notice here that I'm using the literal constructor for dict. As much as possible, try to use the literal built-in stuff for your data structures. Try to use the built-in data structures rather than inventing your own, because these things are highly optimized, and if you're using the literal constructors versus saying dict, Python actually takes some shortcuts and can build that a little bit faster. So places where I actually have to build objects, pretty much every Falcon tries to avoid constructing a lot of objects for every request because that's kind of slow. But it does construct a unique request and response object, keep things isolated, right? And so I need to keep these init functions really fast. So that's just kind of a simple little trick you can do. Okay, so here we have a few examples of things. You notice I'm explicitly testing for none. Might be not so idiomatic. I mean, I should just say if transform. But it turns out that explicitly if testing is none is a little bit faster. I'm using list comprehensions here. That's kind of a common thing you'll hear. Move the for loop into C land. So, and yeah, I think that's all I'm going to talk about there. There's this thing I like to call don't repeat your computations. So kind of a canonical example is compiling your regular expressions up front. So you compile it once, and then you can use it over and over again for the lifetime of that app. So it can be tempting to just say re.match and pass in the string right there, but it's actually kind of subtle because the regex engine has to parse that pattern stream every single time. So try to do things up front. This is actually something I learned from the game industry. They pull off a lot of amazing tricks by pre-computing a lot of things up front. So you can tear your hair out because sometimes it takes forever to load a level or something, but a lot of times that's what they're doing, or they'll even pre-compute it and burn it directly onto the game disk and just memory map that right in. So the game industry is actually they have a lot of experience doing performance tuning. Okay, here's another kind of a simple pattern. You notice how I've got this big sort of ugly string concatenation thing going on. You're like, why don't you just use string formatting for that? It turns out for fairly small numbers, up to about 10 or so, string concatenation is faster than formatting. So sometimes we do that a lot, and it actually doesn't, you kind of get used to it, and especially if you only have a few things. It's not a big deal. Yeah, and you can just see kind of the perf note up there. It talks about join. A lot of times people say use this counterage and then just join the whole thing. Again, you have to look at that on a case-by-case basis. Sometimes it's faster, sometimes it's not. It really depends on the number of items that you're doing. Okay, so here, I'm trying to remember what I had this here for. Well, I'm sure it was really good.
It's probably 9204, right? So 9204 was extract the method and then don't say.
Yeah, that's right. Okay, so that's another kind of, so that's why it's in the basic thing. You'll hear this a lot. Try to avoid dot, try to resolve names up front as much as you can, and then reuse that, because every time you see that dot, Python actually has to do basically like a dip lookup. And it's gotten faster, faster in 2.7, I believe, than 2.6 and stuff like that. But still, it'll shave a few microseconds at least. And it also, if you have a loop where you're doing this 1,000 times, obviously it's going to be much more beneficial. Okay, so let's do some intermediate patterns here. Some frameworks will construct the targets of the routes and things like that. They'll construct new objects for every single time. I've tried really hard with Falcon not to do that because in Python, obviously, creating objects can be pretty expensive. So this is just an example where I would create my resource and I pass that in to my route, and it just lives forever. Okay, the consequence of this, you got to worry about thread safety, but given that by and large we're talking about doing single-threaded evented I/O processes anymore with web servers, shouldn't be a problem. But that's one of those trade-offs you have to think about. Okay, so this isn't the greatest example. I have trouble coming up with one, but the concept is keep your call stacks shallow. So this is the call method that happens on that API object. So this is actually a whiskey callable. If you're familiar with whiskey, you can see that at the top, takes environment and start response. But pretty much this whole method is only goes one more step. It tries to keep the stack shallow. So it'll call some helper methods, but those helper methods generally don't call anything else. with Python, when you start calling a bunch of methods and they call other methods, it can really bog things down. Okay, so this next one is what I like to call flattening your namespace. So this is another way to reduce the number of dots that you have to, dot lookups that you have to put in your code. A couple of ways to do that. I'm sure there are much more, but here are just a couple examples. The top one is this method I call Fleecing, where you can pull things up into your underscore init underscore pi. So it saves you a couple extra dots, so I don't have to say dot package dot whatever. I can just do dot package dot whatever. And this little trick here is just a way to keep PyFlakes happy, so it doesn't complain that you're not actually using something you imported. The second one here is, instead of saying creating a HTTP module and putting in there a bunch of definitions like project owner not responding, that would be the actual name, so I'd have to say http.project owner not responding. And then maybe if I want to get that code, I'd have to be like .code, and then it would give me 780, and then I'd have to say .message, and then I'd have to smush all that together when I'm building up the response. I'm just going to do all that smushing up front. Okay, so it's kind of a different approach. You don't get that kind of, I can reuse the name of my package, so I don't have to say HTTP underscore every time or whatever. I can easily parse out the status code or whatever. But it turns out that you really rarely need to do that, and it's nice to just be able to have everything pre-formatted, ready to go. So this makes it really, really fast and quick to generate the response for the client. And yes, we actually have these kinds of codes just for fun. All the ones are there too, obviously. Except for 200, I don't know how to use that. Okay. So here we have kind of an example of what I like to say called trusting the standard library. There are a lot of modules in there written by some super smart people who've done like tuning them and fixing them for years. The regular expression library is a great example of that. It's a versatile tool. It's pretty darn fast. So I try to leverage it as much as I can for parsing and stuff like that. This is an example of how I'm actually converting a URI template into a regex, so I can do my routing. So it is regex based, but it's kind of hidden from you. The downside of this is you reach a point where it just can't do what you need to do. So if I want to do more advanced things with URI templates, that's probably going to mean writing your own parser. But you want to kind of put off that day as long as you can, right? So look at what you get out of the box. Try to leverage it as much as you can. Okay, advanced patterns, may or may not seem advanced, but again, just kind of building on the things you had before. Closures. So prefer closures over classes. Classes can be really nice, but there's a significant class of things you're trying to do with classes that you can do just as well with closures. And it turns out closures are faster to construct and for them to access their variables. So if you're basically just packaging up a few bits of data with a single action, and you need to send that somewhere else to do something, you should take a look at closures. They seem kind of crazy at first, but you get used to it. They're not too bad. Except when you try to do anything really interesting. So you can see how it can get a little bit hairy. You get several the code that does the hooks in Falcon is probably the most complicated code in the code base, just because it's employing closures and it gets a little bit hard to reason about. But we have, I didn't mention this earlier, but we have 100% test coverage. Our build breaks if we're missing anything, and we try to test things heavily so that even when we're doing something clever and complicated, we can have confidence that this thing's going to be rock solid. So this is where we are. So this performance pattern is using pre-bound methods. So I'm sure some of you guys are aware that when you access a method on a class, it actually it's almost like a closure. Like you'll take self and you'll attach it to that method, and then you can call it. So it's kind of cool because I can rip that out and I can use it on its own. So Falcon uses that for routes. So it's looking in your resource classes, and it's basically ripping out what I call responders. That's the on get, the on head, whatever. And it pulls that out and it uses it directly. So it saves that binding step, and it makes your routing a lot faster because it can just go directly with that method and throw in the self variable. And bonus points if you use duck typing there. Try to do that. Okay, so this one's something that came in the last release, or entity. I actually learned it from that Swift WebOb. And the principle here is try to be lazy and try to reason about, try to optimize for the most common use cases. You can see some comments here where, I could pre-parse all the headers up front and make them all beautiful and pretty, but a lot of that effort would go wasted most of the time. You can still do that. You could create a before hook or something in your app if you wanted to do that on your own, but the choice is yours. Falcon tries to be lazy and try to make smart decisions about the common use cases to make those fast. So it's here, you see it's just using the whiskey environment directly and fixing up your requests for headers so that they look like a whiskey environment variable. And then it uses it that way. So so a lot of times you may not even want to look up some of the headers. And this saves you from having to do that extra work when you don't need to. So be lazy. Let's see, I'm trying to remember what this one was. Yeah, it's just another example of what we were doing before. Oh, right. I got these mixed up. So what I just said actually applied to this one. You're like, what is he talking about? So this one is actually where we do expect people to call it a few times, possibly, and so it still follows the lazy principle, where I'm not going to build up this fancy, nice dictionary unless you ask me for it. But since there's a chance you might call me again, I'm going to go ahead and memoize that. I'm going to cache it right there, and it's almost free for me to do that, so I might as well. And so if you call me again, it's really fast. I don't have to rebuild that. Again, this is like this also plays into that thing we were talking about earlier about. Do your calculations once, and no more if you can help it.
So go back to the next slide.
Which one?
Right there.
Yeah.
So if not cached headers, then headers equals cached headers. Just an empty dict.
So yeah, it's an empty dict. It gets initialized to an empty dict.
Just say it.
Yeah, and then we copied headers and yeah. Because see, this is in a for loop, so I want to make sure that I'm caching that lookup on cache headers. So this one's still fairly new. It'll probably, might evolve a little bit, but pretty happy with it. Okay, so this is another thing where, so this one is kind of like, don't trust the standard library. So sometimes you can, sometimes you can't, but you always got to be a little skeptical. You might, so this was originally written to, like it said, take a, I actually used a list, I believe it was a list comprehension and threw it in the dict constructor, and I thought surely that would be faster because the dict constructor is just going to do that in CLand, but turned out not to be the case. It's actually faster to do the manual loop here and set them directly. So you never know.
Is it still faster even if you use the new dictionary comprehensions to create a dictionary?
Yes. Yeah, I did try the dictionary comprehensions too. It's pretty close, but and again, it can be a function of how many things you actually have to iterate over. You can tip the balance, either way. But in this case, we don't expect a query string to have 1,000 parameters. If your API does, I got a guy you can talk to fix that problem.
So you're building these for a very, very specific version of Python, because those things can change from version to version, right?
Yes. So I test on Pi 2.6, 2.7, PyPy, and Pi 3.3. And there are some cases where, so map is an example. Map is actually slower on Python 3 than a list comprehension. But on 2.7, map is a little bit faster. So if the thing I'm doing is already, blazing fast on Python 3, and maybe it's a little faster than using something else, I have a little bit of fudge room, and I might decide, okay, maybe I still will use map here because it's a pretty good trade-off. Because I need to make this specific method really fast on Python 2.7, I have to do some more work. Maybe easier to make that fast on Python 3.3, some of the other statements. And so I might choose, to use map in that case. Does that make sense? So it is tricky because you're trying to kind of do it for all the different versions. But by and large, Python 3 and Python 2 are where you'll see the biggest differences. But it's not too different. More often than not, you'll do something that'll speed up an older version of Python, but not the newer version. And so you just leave it in because it's not hurting anything.
So this brings up the big question. I'm just looking at your benchmark data. And the Python 3.3 is significantly slower than the Python 2.7.6.
Yeah, and you'll see that across the board with all the frameworks.
Yeah, that was clear. But
Yeah.
The question is why?
That's a good question. So I'm not a Python core hacker myself. The only thing that so I do know that some of the Unicode stuff that Python 3 does is a little more expensive. So if you're doing a lot of string handling, it can be a little slower. But other things, that's a great question. Maybe we can have a talk here sometime from Alex or Jesse Mulder, some of the core contributors, and they can kind of speak to that.
And probably Unicode has something to do with that. So.
Yeah. Yeah, I think that is a fair chunk of it. Some of the standard library implementations are different, and mostly because they're better and more robust, but they do actually do a little more work.
You mentioned something interesting, which is map, as an example that you used. In Python 2.x, it returns a list. In Python 3.x, it returns an iterator. Is that something that gets exposed by your API, or is that, for example,
sorry, when I was talking map, I meant the function, where you pass in, you pass in a lambda or a function to iterate over a set and transform it.
You're still right that is the difference between 2 and 3.
Yes. So the dot.ims thing, I think might actually have that. We did run into that. Let me think about that. We can come back to it. But yeah, that does ring a bell. I think I had to do something there. Now you can when you come across something like that, you can normalize it. You can just pass it in a list. But if it's already a list, you're actually wasting some time. So I think there are a few places where I'll actually. So Falcon, one of the two dependencies Falcon has is on the 6 library. So there are a few places where it'll actually branch depending on what version of Python they be running. So in Python 2, it will just return the thing directly, the map, the dict.items, or on Python 3, it would wrap it in a list. So that does slow down. That could be an instance where you're taking a performance hit in Python. Because if you don't need it as an iterator, you really want it as a list, well, there's nothing you can do about that because they don't have a way to access just the list. I could be wrong.
But the whole point of sending it as an iterator is to save the memory allocation, and memory allocation is a big, expensive thing.
Right, so
I mean, passing iterators around is generally a big win.
Well, again, it depends on your data set. If you have a very small data set, it doesn't really help you and it slows you down. If you have a big data set, yes, definitely. You don't have to pull that whole thing in memory at once.
Allocations hurt you all the time, every time you do it.
Okay, let's see. So this is also okay. You're gonna probably think I'm insane and crazy, and we're never gonna use Falcon again. But for a while we were using URL-lib, quote and unquote, and in this last version we actually replaced them because they were very slow. They turned out to be the bottleneck of the whole chain, and not only that, but URL-lib in Python 2 kind of bars encoded URIs. It defaults to the Lat 1 character set, and there's not much you can do about that. You can kind of try to fix it up after the fact. So we did kind of bite the bullet and take some time to do that. And so, but again, we didn't just start from scratch. We actually looked at the URL-lib source code, tried to clean it up, make some simplifying assumptions based on what we know from common modern API design patterns. And we try to short circuit things as much as we can. And so we tried a bunch of different things. So we ended up with this. Now I will say that it scared me to death to actually do this because it can be kind of complicated to decode and code stuff. I mean, it's not that bad, but it's easy to make a little mistake. So what we actually did put in our test suite was generate a bunch of random strings, and we'll quote and unquote them using URL-lib, and then also using Falcon's decoding code utilities, and just make sure that they're exactly the same. So we're kind of testing against URL-lib as our baseline, make sure we didn't make any mistakes. So this actually made us fair amount faster. And we kind of got forced into doing this because we wanted to do more robust decoding and be able to handle the UTF-8% encoded strings if you had them. And doing all that takes time, and we wanted to offset that time. So sometimes that will happen. You'll add new features that will slow you down, and you'll have to kind of look at other ways to optimize your app to offset that slowdown. Now, usually this is an anti-pattern, I would say, when you're trying to make your code as efficient as possible. You want to avoid doing magic methods because that causes the runtime to have to call you back every single time, and it takes some time. So if you do have to do it, sometimes it's really useful and handy. I kind of cheated. I pulled this from OpenStack Marconi project, which actually uses Falcon. But this part isn't part of that. It turned out to be really, really super useful to override the getAttr attribute, and it's kind of a common thing to do in Python land. But that's way slower than just accessing a first-class attribute. So we created this decorator up here at the top, and what it actually does is it basically will memorize each call. So it'll detect that it creates an actual attribute on your class. Yeah. Okay, so and you can kind of see some of the stuff, magic stuff we're doing here is a little bit expensive. We're doing some introspection. So this decorator at the top will actually tack on. So if I say .foo, foo doesn't exist, I come in here, it's actually going to add a .foo attribute to the class that this is a member of. So the next time someone calls it, it's really fast. So if you have to do it, try to either memorize it or just minimize what you're doing in there. One other thing to watch out for is Falcon does include a case-insensitive dict for its part of its utility library. It's only actually used in some of the testing utilities that you get with Falcon. And the reason for that is, to do things like a case-insensitive dict, you have to override all kinds of matching methods, and it's much slower than, obviously using something that's built into the runtime, just using the stock dict that is highly optimized in C. So just to recap here, we're just about done. Lessons learned, the Rackspaces were developing this Falcon framework. Algorithms and schemas. So when I say schemas, I'm talking like database design, data models. I didn't touch on that earlier, but that's another opportunity for reducing the amount of work you have to do to look things up. Okay, so you're gonna obviously want to look there first. You're gonna want to pull out your big O notation and think through that, okay? But pretty quickly, you're going to have to do some other things. I mentioned winning in the margins. A lot of these things save a microsecond here, 10, 20, 100 microseconds there, but they all add up. And if you can save 10, 20 milliseconds, make a big difference. Simple trumps complex. So if you get Falcon, take it for a ride. You're going to notice it's pretty bare bones. It doesn't do a lot of magical things. It doesn't bring world peace. But the benefit you get out of that is it's crazy fast, and it's really easy to reason about. So if something goes wrong, it's pretty easy to figure out what happened. Explicit trumps implicit. So try to, again, that goes back to the magic stuff, and trying to use literals for constructing things and all that good stuff. Data trumps speculation. So I came across numerous times where I thought this would be faster than that, and it turned out to be the exact opposite. So you're always testing and profiling and watching what goes on. Okay, I mentioned don't repeat your computations. Try to pre-calculate stuff up front. It can take a lot of forms, from pre-compiling regexes to pre-concatenating strings to doing math. If you're doing something mathy, try to pre-calculate parts of your formulas up front, all that good stuff. But of course, trade-offs are unacceptable. You have some tricky situations when you're looking at usability versus performance, or Python 2 versus Python 3, and you just have to be really smart and try to optimize for the most common use cases. And then, of course, you ain't gonna need it, so try to avoid adding extra stuff that may or may not be used. And because if you try to do too much up front for the user, there's a bunch of calculations and stuff that's wasted, because most of the time the app isn't going to need all that information that you just set up for it. So that kind of goes into the lazy parsing idea. try to wait until the last possible moment to compute something. I guess that's kind of the opposite of don't repeat your computations, but trade-offs. Okay, so we talked a lot about we talked some about the philosophy that went into the design of Falcon. We talked about the performance lessons that we've learned, and I guess I want to leave you with this thought that it's important to keep striving, and again, feel free to reinvent the wheel, because if nothing else, you'll learn through that process, and you'll be able to share that knowledge with the community. And as we build on each other's stuff, things just get better and better. And so I encourage everyone to collaborate on your projects, share your ideas, and let's make the community better for everybody. Okay, so we've been answering some questions throughout, but we'll have a few more minutes here at the end. Just real quick, the repository there is for Falcon. You might have probably found it if you saw the website already. There's this new project spinning up called Talons, which is kind of like your batteries included part of Falcon, I guess. It's going to add lots of nice hooks and stuff that people keep having to do over and over again. And this is kind of a model that we borrowed from the Node community, where they keep the core kernel of Node minimal and lean and fast, and then you have all these ancillary projects that support it. If you want to check out my blog there at blog.krush.com. I'm always on the Falcon framework and in the OpenStack Archive channel on Freenode. And hit me up there on Twitter or get me. Okay, so, questions?
This is kind of an open-ended question, but so the performance, like all your various performance hacks or whatever, the various things that you did to balance it is interesting to see. But there's a part of me that's always like, so there's productivity trade-offs whenever you ask someone to, when using a syntactic sugar in order to use it to I guess my question is, you're using a language like Python, which is not necessarily known for its performance so much as its ease of use. So, it's like I was curious about what your thought process was, how you balance those sorts of decisions. When do you trade off ease of use first, to gain some sort of performance gain, and why not just write those pieces in a language that's better suited to performance, if that's what you're doing?
Yeah, that's a great question. I mean, if you come to the Python community because of the ease of use, you may say, well, there's kind of an impedance mismatch between this and Falcon. So I don't know if there's like a magic formula. I've tried really hard to keep those in balance as much as I can. There is a time when the best tool for the job is not even going to be Python. But sometimes you do need to use it. Part of that may be because the ecosystem that you're building for either demands it or you're able to kind of leverage the expertise of your team because they all know Python, but they don't know this other thing. So there are kind of a lot of not more political or more just team compositional things that you have to keep in mind when you're choosing a platform. Now, could I have written done this project in Node? Yeah. But there are a bunch of other things, benefits we got from choosing Python. So basically we just said, oh, let's try to get the most we can out of what we've got.
So I guess the follow-up question.
Yeah.
You had the option of potentially writing pieces of it as C extensions, but did you want to keep it as pure Python? Because it seems like if you're performance, then there are other opportunities that.
Right. So that has been an idea we've been playing around with. We just haven't gotten there yet. It is nice to kind of at least have. I think if we did that, we would probably. Lots of trade-offs. One thing that kind of holds me back from doing that is that PyPy has actually come a long ways, and if you run this under PyPy, it's just screaming fast. And at that point, it's almost, diminishing returns to try to go down to CLAN and into that. But probably the place that we might end up doing that though is with the route parser when we go to support full URI templates. If anywhere, that'd probably be where we do it. Yeah.
First, thank you very much for making this talk. I very much appreciate it. What I came expecting was actually a discussion of Falcon. I very much would want to encourage you to come give a talk on Falcon.
Yeah.
Why it is elegant and all those things, because you gave a lot of performance tweaks, but I actually don't know why I would use you because of your elegance argument versus Tornado versus Flask versus anything else.
Yeah, that's great feedback.
I will spot you that I should, okay, but I would love to have you come and tell me all the awesomeness and compare and contrast against the people. It's okay to kick dirt on them, right? It is okay. We want to find, because we want to know to find out.
Yeah, we want to have a healthy, open discussion about all the alternatives, right? Yeah, I realized this was kind of a grab bag of stuff. I had a lot I wanted to cover, but certainly happy to talk more about the specifics of actually using the framework. And on that note, we are starting to work on our docs finally. We've always had really good doc strings, but that's not that doesn't really cut it, I realize. And so once we have, we'll have. Anyway, I kind of see that as part of the documentation effort, and also that I think would be great, like you said, to put together a talk that just covers a walkthrough of building up an app in Falcon. So that's great feedback. Yeah.
And my follow-up is, one of the challenges that all of these frameworks have, Flask 2 years ago, probably said the exact same things you did. We're not going to do all of this stuff.
Mm-hmm.
Now they've done all of this web framework stuff.
Yeah.
Right, but we have a situation where we're trying to build single-page web applications,
Right.
which really means we have a REST app server and a web server that brings up the single-page app that everyone bangs on the server.
Mm-hmm.
So I would really love to see how you solve that problem and how you're going to defend yourself from becoming a web server as opposed to staying a REST app server, which is what I want you to be.
Yeah.
I want the REST app server. I want it very clean and fast.
Yes, no, that's a great observation. And we've started to see some of that already. We get people coming in and they want things like form parsing, and we have to decide, well, it's kind of like in HTML forms, like you don't usually use that when you're just building like a backend for a one-page app, for example. So yeah, it's tough. I think you have to be very, so one way to combat that is to kind of define, draw the line in the sand. I mean, kind of define the framework around where you decide what things to add and what not. And so whenever you have a question, you go back to that. Yeah, I don't know if I have a great answer for that, though. It's something I'd love to chat more about and think about. Yeah.
Well, along the lines of when people start wanting more functionality to do different templates and such, what if you could design this framework to just be compatible with stuff?
Yeah. So actually, that's great. That reminds me, like the Talents project. You can do all kinds of stuff with the hooks, and you can add things like form parsing or template generation and stuff like that. So I think it's going to be interesting to see how that evolves, how the Talents project evolves, and what other kinds of projects kind of pop up to fill that gap. So yeah, that could be a good way to kind of direct that, so we keep the core lean and mean. Yeah, in the back.
Yeah, I just want to say this is really impressive. Your benchmarks are just crazy fast.
Mm-hmm.
You have a sense of what makes Flask so much slower than this? Is it Do they have like one or two like big bottlenecks you got around, or is it just optimizations everywhere that you can add it up?
So I'm not sure. I haven't actually profiled Flask heavily. I tend to like focus, just on Falcon. I think that would be a great avenue to explore, like starting to really track down some of those bottlenecks. I do know some of the issues that Pecan has. I'm not familiar with that one. But I'd love to get more contributions from the community where we can dig in and kind of to learn and grow together. Because I'm not trying to kind of, destroy all of the frameworks, right? Like we want to grow everybody and we want to share these lessons. And but I suspect with Flask, it's going to be reliance on. Well, I know Flask does like a lot of magic stuff. It's creating a lot of objects. It's going to be probably using like URL lib and some of the other standard things that end up actually be a little bit slower. But yeah, Flask has been around a long time, battle-tested, great framework, so we should keep looking into those things and trying to learn from them. Any other comments? Okay. All right, guys, I think we're done. Thank you.